Hello students, hope you are doing well. So today we are going to start the next module, which is module 6. Module 6. And guess what? This is about rotational dynamics. Rotational dynamics, right? So this chapter or this module is going to divided into many sessions, of course, but we'll trying to keep the important topics as far as the main is concerned, right? So let's start. So first of all, in this chapter we will discuss about rotational kinematics, which is nothing but related with motion and many important terms. This chapter has lot of applications and it's quite vast, So let's start with first as rotational motion, that we see as rotational kinematics. Rotational motion, or it is the kinematics part. Kinematics. Okay. So in rotational motion or rotational kinematics, what are the important things that we are going to discuss, right? So let us understand first is what about rotational motion. Just like when you study motion, you study distance, displacement, all that. So same way, first topic that comes here is, so it is also a part of circular motion will be a part of it, but it can go beyond circular motion. So let's understand first thing, that is called angular displacement. Angular displacement. What is angular displacement? Now suppose if you take a point, right? This is a point which will have some coordinate x comma y comma z with respect to a particular coordinate system, isn't it? Suppose this x, y, z with respect to a particular coordinate system, and this is 0 comma 0 comma 0. Now first of all, we'll connect a vector like this. This is called position vector. This is r vector. Now suppose with respect to point O, this P is moving. Of course it is moving. It's not that the point P has to go in a circular motion, but here if you consider rotation, let us consider a case like it is going in this direction. Let us consider it is moving in a circle, because we are going to keep it like a rotational motion. So but it is not necessarily it has to go in a circle. We'll discuss more detail about the complexities involved, but let's first understand that it is going to move in a path, and let us say after some time it comes here or somewhere, some other point it goes. And right now, what is angular position? We should try to understand. So with respect to the positive x-axis, this angle measured in this direction, that angle is taken as positive, right? Anti-clockwise angle is considered as positive, and clockwise angle measurement is taken as negative. This is just like towards right side, towards left side. So direction, it has direction. So angular displacement has direction, which you write as delta theta. So either it will be clockwise or anti-clockwise. So but angular position itself is a vector quantity. It is a vector, but this is called rotational vector. It's not like a normal vector, but it is like a rotational vector. Okay, so this theta will be like a vector quantity. It has direction and it should be treated like a vector. It follows the law of vectors. So first of all, the angular position theta is defined with respect to x-axis, the radius vector, how much angle it is making with respect to positive x-axis, isn't it? That's the angular position. Now angular displacement is, suppose this particle, let's say considering circular motion, it is going from here to here. So its angular position, that means this is theta 1, let us say, and now it is theta 2, right? Of course with proper sign, this is positive angles. So the displacement, angular displacement delta theta will be theta 2 minus theta 1. Isn't it? Just like we write in a case of displacement x2 minus x1. In case of linear displacement, exactly same manner, this angular displacement is theta 2 minus theta 1. It can be positive if theta 2 is increasing, that means it's going in anti-clockwise direction, and if delta theta is negative, so theta 2 is decreasing. Okay, and this is theta 2 minus theta 1. So angle is decreasing, then it will go in clockwise direction, right? That's what is angular displacement. Then now let's understand next angular velocity. Angular velocity. So what is angular velocity? Angular velocity is defined by the symbol omega, and it is defined as the rate of change of angular position d theta by dt, right? This is the instantaneous. Of course, average, when you take average is delta theta by delta t. So this d theta by dt is nothing but when you apply limit delta t tends to 0, delta theta by delta t. So that becomes d theta by dt. You know that. This is what is omega, angular velocity. So the rate at which the angle is changing, that is known as angular velocity. It is the rate at which angular position changes. That is what it is, angular velocity. Okay, and it is also positive, negative. If your body is going in this direction, so omega will be positive, and if your body is going in this direction or rotating in this direction, it's going to be negative, right? By convention we take that clockwise or anti-clockwise. So this is anti-clockwise, and this is clockwise, right? Okay. Then what about angular acceleration? Let's understand in the same manner angular acceleration. Angular acceleration, this is defined by the symbol alpha. So what is angular acceleration? Angular acceleration alpha is rate of change of angular velocity. So alpha is rate of change of angular velocity. Just like in case of rate of change of linear velocity is linear acceleration, same way angular velocity, rate of change of angular velocity is angular acceleration. Okay, again this is instantaneous. If you want average, so average value of angular acceleration is delta omega by delta t, and this is nothing but when you try to take limit delta t tends to 0, that's why it becomes delta omega by delta t ratio only. But when you take limit delta tends to 0, that's how we consider, isn't it, the definition of this, isn't it, instantaneous. Okay, right, that's the basic definition about it. Now there is relationship between the linear variables and angular variables that we will try to understand, right? So let's understand, for a very small angular displacement d theta, we can take d theta. Angular displacement is small. Okay, so there will be small arc length which is going. So you may write this as a small displacement, but this is of course a vector quantity. You may write like this, very small angular displacement, and this is vector, so you may write as dr vector, isn't it? Okay. So about this, of course, center, this body is moving. It may not move also in the same circle. The radius may also change, but at a given instant change may not be much. So this is dr vector, but it may change also, right? Radius also, but assuming that radius is not changing, it's going in a circular path. We are making this assumption that body is going in a circular path, right? So this is a very small circular arc that we are considering here. It is almost like a straight line, isn't it? So here this d theta, all of us know the angle is arc length divided by radius. Let's say radius is r, capital R is radius. So this definition, angle in radian, all of us know, right? This is the relationship between that. That's why you know the arc length or dr is equal to r d theta. Here what is dr? You should remember dr is instantaneous displacement, and of course it is magnitude only. It is the magnitude of instantaneous displacement, or you can say it is instantaneous distance. Okay, so this dr is the instantaneous distance or magnitude of instantaneous displacement. Okay, so that is what it is. Dr is equal to r d theta. Second, let's go to the second. So if you take omega is nothing but d theta by dt. So here you can put dr by dt and this r will come out, right? So from here you can understand that omega is dr by dt is nothing but speed. Remember, dr by dt is speed. Okay, here v refers to speed, which is also magnitude of instantaneous velocity. Instantaneous velocity magnitude is called speed at that particular point, right? So this is what the relation between v and omega, or you may say v equal to omega r. That is what we generally write, isn't it? Then the third relation will be when you calculate alpha. Alpha will be d omega by dt. So here same way you have to do dv by dt and r factor will come out. Now dv by dt is what? dv by dt is the rate of change of instantaneous velocity at that point, right? So this is the acceleration, which we say is called tangential acceleration. Okay, this is called tangential acceleration divided by r. Okay, it is the tangential acceleration. So that's why from here you may also write this as tangential acceleration is equal to r alpha, isn't it? So all these relations are useful relation between the linear variables and the rotational variables, right? So first of all we should know this. So then further we will discuss more about this, right? Thank you for your attention.